Okay, moving on to more log stuff, section 3.3 in our book, properties of logs. Let's see, expand each logarithmic expression. This is where we need to write it as addition or multiplication. So remember, anything in the numerator, if you're multiplying, you split into addition. So this is going to be ln of x squared plus the ln of y. And then I'm dividing by ln of the cubed root of z. So ln cubed root of z is going to be subtracted. Anything that's divided is translated into subtraction. Then the last thing I need to do is pull down my exponents. So the 2x squared is going to come down front. And something else, the cubed root of z, you need to know that the cubed root of z is actually the same thing as ln of z to the 1/3 power. Cube root of z is the ln of z to the 1/3, which means I can pull that exponent of 1/3, I can pull it down in front of the ln z. And that's what we're going to do for this problem. So this final answer is going to be 3 times the natural log of x plus the ln of y minus, and I'll pull that 1/3 down, ln z, and there we go. There's our answer for number 16. Here's another one. Log base 2 of, I see x plus 3. And what you have to remember here is you cannot separate the addition. If it's x plus 3, you just have to keep that as one big thing. So it's going to be log base 2 of x plus 3. But then I'm dividing by y times z to the 8th. So I'm going to do minus log base 2 of y. And I'm also dividing by z to the 8th. So I'm going to do minus log base 2 of z to the 8th. And then the last thing I need to do is pull that exponent down. Z to the 8th, I can pull that down in front, make that 8 times log base 2 of z. So my final answer, log base 2 of x plus 3 minus log base 2 of y minus 8 log base 2 of z. There's our answer for 17. Good. Wonderful. Let's see. Okay, going in the opposite direction, now we're going to condense. I'm giving you a whole bunch of logs. I want you to write it as a single log. So I'm going to do the opposite, or do the same thing I was just doing. Hey, my phone's ringing. All right, so back to this one. To condense this, first thing we're going to do is bring our exponents back up to the top. So we're going to move in the exact opposite direction. So my coefficients need to become exponents. So bring my 5 up, bring my 1/2 up on the z. And so that's going to be log base 2 of x to the 5th minus. Okay, I decided just to pause it and write the answer because we're bringing up those exponents. Now, you do have the option if you want. It makes no difference to me whatsoever, but z to the 1/2 is the same thing as the square root of z. So if it makes you feel better to write it as the square root of z, then do that. I won't count off if you leave it like this. So now we need to write this as one single log. They're all base 2, so I can write this as one big massive log. And remember, anything that's positive goes in the numerator. Anything that's negative goes in the denominator. So I have x to the 5th. That is a positive log. There's no sign there, so it's an understood positive. So x to the 5th minus the log of y plus 1. That means y plus 1 is going to go down here. Then plus, that's a positive log, z to the 1/2. Or if you want to write that as the square root of z, you can. Either one is perfectly fine. And that's going to be our final answer. Positive logs go in the numerator. Negative logs go in the denominator. Okay, doing the same thing. This is natural log. We're going to start off by pulling up these exponents. And somebody asked this question in class the other day. I would leave the negatives down. You do have the option of pulling the negative up with it, make it y to the -2, but that's going to be really, I just see potential sign errors there. So let's not do that. Let's just bring up the coefficient, or the coefficients, and leave the signs as they are, like that. And then one thing I noticed, the way I drew my arrow for the 5, I need to stretch it out a little bit because the exponent needs to apply to both the 1 and the minus z. So make sure when you do the stuff to the 5th power, you have the 1 minus z in parentheses all to the 5th power. Now we will write all this as one big log. That is a positive ln x, so x is going to go in the numerator. A negative ln y squared, so y squared is going to go down here. And negative ln of that stuff, so 1 minus z to the fifth will also go in the denominator. And there's our answer for 19. Evaluating with the calculator. Now these problems you just punch straight into a calculator. There is a change of base formula, and the way you'll do this is you will type in log base 5 of 12 is the same thing as the ln of 12 over the ln of 5, or you could do it as log of 12 over log 5. Either one works because your calculator has both of those buttons on it, or log 12 over log 5. You just punch those in the calculator. And when you punch in this first one, you get 1.544. I was going to put the calculator on the screen, but the computer's not working. I can't get the video to show up right. Make sure, though, when you punch this in the calculator, like I like to use the ln button. TI-89's that log function is in the catalog, but ln is on the main. You can use a button for ln. Just make sure that when you punch it in, you close the parentheses after the 12, and then we'll do divided by, and then when you hit ln, it automatically opens parentheses of 5, and once you punch that in the calculator, it gives you 1.544. Same thing for number 21. I'm going to type it in as the ln of 17 divided by the ln of, and it's 1/3, so we'll have to make sure we get the 1/3 in parentheses, so let me punch that in real quick, and I get negative 2.579. And pay attention to the directions. It says round decimals to the third decimal. You need to know how to round to the third decimal. Make sure you do that. It always bugs me when I say explicitly what to do, and then somebody just writes negative 2.6, which means they knew how to do the problem, but they lose points because you can't follow directions. So make sure you follow directions. It's a good skill to learn anyway, especially when you get married and your wife is telling you everything that you have to do. Okay, sorry, getting personal there. All right, so write the following in terms of ln3 and or ln of 7. Now, this is an application of that expanding and condensing logs, where my challenge is to write these numbers, 63, 147, and 343 over 729, as only 3s and 7s. Hey, I have a reminder. Let's see. Watch the stairwell. I guess I got to go watch the stairwell. Yeah, it's 7:45. All right, back from stairwell duty. So now I need to turn 63 into numbers of into 3s and 7s. I know that 63 is 9 times 7, right? Hopefully you know that. And 9 times 7, I have my 7, but I still need 3, so I need to turn 9 into terms of 3. So 9 is 3 squared times 7. And now if I have ln of something times something, you can split that into ln of 3 squared plus the ln of 7. Remember, multiplication can be split with addition. And then the last thing we're going to do is pull this 2 down. Exponents are going to come down as coefficients, giving me a final answer of 2 times the ln of 3 plus the ln of 7. There we go. And my next one, 147, I'm going to try to do the same thing and play around with it on the calculator. I know 7 is going to go into 147 21 times. So I have 7 times 21, and then 21 is 7 times 3. So I'll turn 21 into 7 times 3. And now I have all 7s and 3s, and I can split this up into the ln of 7 plus the ln of 7 plus the ln of 3. And if you really wanted, I'm okay if you stop right there. But I have 2 ln 7s, which can be combined into 2 ln 7 plus the ln of 3. I would accept either one of those answers. You don't have to combine those two, but just showing you that that is indeed an option. So, number 24, 343. I know I have to deal with 7s and 3s, so I'm going to have my calculator here. 343 divided by 7, just playing along, is 49. So that's ln of 343 is 7 times 49. 729, I guess I'll divide that by 7 also. Let's see what I get. Okay, that doesn't divide nicely, so let's do 729 divided by 3, and you get 243. And then I want to keep breaking those up. Now, 49 is easy. I know my numerator is going to be 7 times, and 49 is also 7 times 7. Okay, 243, however, doesn't come off the top of my head, so I'm going to do 243 divided by 3, and that gives me 81. So 243 is 3 times 81, and then we can keep going with that. That's going to be ln of 7 times 7 times 7 is 7 cubed, so I'm just going to rewrite it as 7 cubed, and 81 is 9 times 9, right? And I just keep going, and I keep breaking these numbers down until I have all 3's and 3's. And now the end is near. I'm starting to see where this is going. I have 7 cubed over, and then each of these 9's can be written as 3 squared, right? Or 3 times 3. So I have 3 times 3 already, and then the 9 that I circled green is also 3 times 3. And then the 9 that I circled red is also 3 times 3. I have a buttload of 3's down there. And then we'll finish cleaning that up as ln of 7 cubed. 1, 2, 3, 4, 5, 6 3's over 3 to the 6. And now finally I can split this up. I am dividing inside my log, so that's going to be ln of 7 cubed minus the ln of 3 to the 6. And then lastly, I will bring down those exponents to make it 3 times the natural log of 7 minus 6 times the natural log of 3. And I got those by pulling these exponents and moving them to the front. Yeah? Yeah. So that one took a little bit of time to fish through, but at least you know you're dealing with 3's and 7's. So you didn't have a whole lot to have to test. It just took a little bit of time. Let's see, evaluate without a calculator. Okay, this is the same stuff we were doing earlier, where we're going to set this equal to x and take it out of log form. So this is 3 to the x power is equal to the 6th root of 27. And then we need to play with that. Remember, you want both sides to have the same base. So my left side doesn't break down anymore. 3 to the x is as simple as it's going to get. The 6th root of 27 is the same thing as 27 to the 1/6 power. And then I need to start cleaning up. 27 is the same thing as 3 cubed. So I'll turn 27 into 3 cubed to the 1/6. Well, what was that? 1/6. And so I get 3 to the x. My left side is just 3 to the x. When you have a power to a power, you multiply. So 3 to the 3 times 1/6 is going to be 3 to the 3 over 6. And then you set the exponents equal. And we get x is equal to 3/6. And if you're incredibly smart, all right, if you're incredibly smart, then you know that 3/6 is the same thing as 1/2. There we go. Let's try the next one. Log base 7 of that. Again, I'm going to set this equal to x. But before I take it out of log form, you've got to take care of this coefficient. You cannot have coefficients of the log. So I'm going to pull that up front. And that's going to give me log base 7 of, and I'm going to change 49. The 6th root of 49 is 49 to the 1/6. And all of that is cubed because I pulled that 3 up and I changed the 6th root of 49 to 49 to the 1/6 equals x. And now I can take it out of log form. I don't have any coefficients, so 7 to the x power is equal to 49 to the 1/6. All to the cubed. And there's a couple of different directions you can go with this. I have a power to a power, so I guess I could go ahead and multiply those exponents and change that to 49 to the 1/6 times 3 is 3/6, but that's 1/2, so 49 to the 1/2. And now I'm going to change 49 into a 7, so that's 7 squared. That's not a 2. 7 squared to the 1/2 is equal to 7 to the x. And when you multiply those exponents, 2 times 1/2 is 1, and x is 1. Yeah. Last one in this section. Oh, that was the last one in this section. Hey, it's a blank page. Let's draw Triangle Man. Blah, 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 blah. It's a big bold Triangle Man. All right.